Right now, you are sitting on a small rocky planet orbiting an ordinary star. That star is just one of hundreds of billions inside our galaxy. Our galaxy is only one among perhaps trillions of galaxies scattered across the observable universe. And yet, everything humanity has ever seen, every civilization, every mountain, every ocean, every book, every war, every dream, exists inside a tiny fraction of reality. Because scientists have discovered something astonishing. The universe we can observe may not be the entire universe. In fact, it may be only a small, visible region inside something vastly larger. Something that could extend forever. No edge, no boundary, no final destination. Imagine boarding an indestructible spacecraft, a ship capable of traveling for billions of years. You leave Earth behind. You pass the moon. You leave the solar system. You cross the Milky Way. Then you continue beyond every galaxy you can see. Millions of years pass, then billions, then trillions. You never stop, and yet, you never find the end. No wall, no cliff, no cosmic barrier, just more space. Forever. Could reality actually work this way? Can something truly be infinite? And if space never ends, what does that mean for you? For humanity? For existence itself? Tonight we're exploring one of the deepest and most unsettling questions in cosmology. What happens if space never ends? Human beings evolved in a world of boundaries. Everywhere we look, things end. A forest eventually gives way to open land. An ocean eventually reaches a shoreline. A continent eventually reaches the sea. Even the atmosphere surrounding Earth has limits. Our brains are built around finite experiences. Whenever we encounter something large, we instinctively assume there's an edge somewhere. If you walked far enough, you'd find it. If you traveled long enough, you'd reach it. That's how almost everything in daily life works. So when people hear that space might be infinite, their first reaction is usually, what's beyond it? It's a reasonable question. But modern physics suggests it may contain a hidden assumption. The assumption that space is an object existing inside something larger. But what if space isn't inside anything? What if space itself is the framework of reality, the stage upon which all events occur? If that's true, and then asking what's beyond space may be similar to asking, what's north of the North Pole? The question sounds meaningful, yet the concept itself breaks down. There may be no outside to space, because space could be all there is. Already we're entering territory where common intuition begins to fail, and things are only getting stranger. When people hear about the size of the universe, they often encounter a staggering number. Roughly 93 billion light-years across. That sounds enormous, and it is. But here's the surprising part. That number does not describe the entire universe. It describes only the observable universe. The observable universe is the region from which light has had enough time to reach us since the beginning of cosmic expansion. Think of it like standing in the middle of a vast fog. You can only see a limited distance. The fog creates a horizon, but that horizon isn't a wall. The world continues beyond it. You simply cannot see farther. The observable universe works the same way. The speed of light limits our vision. Light travels incredibly fast, nearly 300,000 kilometers per second. Yet the universe is so vast that even light has not had enough time to cross all of it. As a result, there are regions of reality forever hidden from us. Not because they don't exist, but because their light has never reached Earth. Right now, there may be galaxies beyond our observable horizon, entire clusters of galaxies, gigantic cosmic structures, civilizations, phenomena, things we cannot even imagine, and we may never know they exist. This realization changes everything, because once we acknowledge that our observable universe is merely a visible bubble, the possibility emerges that reality extends far beyond what we can ever see, perhaps infinitely far. When scientists discuss an infinite universe, they don't necessarily mean an endless empty void. They mean something more specific. They mean that space continues indefinitely without an edge. No matter how far you travel, there is always more space ahead. This idea is difficult to visualize because we instinctively imagine infinity as a straight line stretching forever. But space may not behave that way. Imagine standing on Earth's surface. Thousands of years ago, people thought traveling far enough would eventually bring them to the edge of the world. But it doesn't. You can continue traveling indefinitely because Earth's surface curves back on itself. Interestingly, the universe could behave similarly. Space could be finite but unbounded, meaning it has no edge despite not being infinite, or space could genuinely continue forever. Current observations suggest the geometry of the universe is remarkably flat, and a perfectly flat universe is compatible with infinite extension. The data doesn't prove infinity, but it keeps the possibility very much alive. And if space is truly infinite, the consequences become astonishing. Let's consider something surprising. You are made of atoms, roughly 7 octillion of them. That's a 7 followed by 27 zeros, an absurdly large number, yet despite its size, it remains finite. The same is true for Earth, the solar system, even our galaxy. Everything consists of matter arranged in particular patterns. And while there are an unimaginably large number of possible arrangements, the number is still finite. Now imagine placing those finite possibilities into an infinite universe. Eventually, patterns begin repeating, not because anyone is copying them, not because of some cosmic design, but because infinity gives reality endless opportunities to rearrange matter. Imagine shuffling a deck of cards forever. Sooner or later, the same arrangement appears again. Given enough repetitions, every possible arrangement appears, then repeats, again and again. In an infinite universe, the same logic may apply to matter itself. Somewhere unimaginably distant, another Earth could exist, another solar system, another Milky Way, and perhaps another version of you. Reading these exact words at this exact moment, the distances involved would be incomprehensible. Numbers so large they exceed ordinary understanding. Yet mathematically, infinity makes such possibilities difficult to avoid. Now the idea becomes unsettling. If space never ends, there may not be just one copy of Earth. There could be infinitely many, some nearly identical, others slightly different. Imagine another Earth where one decision changed history, a different election, a different invention, a different war, a different scientific breakthrough. Imagine another version of yourself who chose a different career, moved to a different city, met different people, lived an entirely different life. These aren't parallel universes in the science fiction sense. They would exist within the same infinite cosmos, separated by unimaginable distances, each representing a different arrangement of matter permitted by physics. Some cosmologists have seriously examined this implication, and while it remains speculative, it emerges naturally from certain models of infinite space. The result is one of the strangest conclusions modern science has ever contemplated. You may not be unique, not because you're unimportant, but because infinity creates repetition on scales beyond comprehension. Suppose space never ends and contains infinitely many stars. A paradox immediately appears. It's known as Olber's paradox. The question is simple. If stars fill an infinite universe, why is the night sky dark? Shouldn't every direction eventually end at a star? Shouldn't the sky blaze with light? For centuries, this puzzle baffled astronomers. The solution revealed something profound. The universe is not infinitely old. Light from distant stars hasn't had enough time to reach us. Additionally, cosmic expansion stretches and weakens that light. The darkness of the night sky is evidence that the universe has a history, a beginning to its observable state, and that history matters enormously when discussing infinity. Because even if space is infinite, the observable portion remains limited. We exist inside a visible island surrounded by an ocean we cannot explore. Now imagine an infinite universe that continues expanding forever. This possibility is perhaps the most haunting of all. Galaxies gradually drift apart. Over billions of years, distant galaxies disappear beyond the cosmic horizon. Future civilizations may look into the sky and see only darkness, unable to detect evidence of the Big Bang, unable to discover other galaxies, unable to know the true scale of reality. As trillions of years pass, stars die, galaxies fade, black holes dominate. Then even black holes slowly evaporate. Eventually, the universe may approach a state called heat death, a future where usable energy becomes scarce. No dramatic explosion, no cosmic collapse, just an endless fading, an infinite universe growing colder and emptier for eternity. Imagine existing in such a future, a cosmos stretching forever, yet containing almost nothing. Infinite space, infinite darkness, infinite silence. Perhaps the most frustrating aspect of this mystery is that we may never obtain a definitive answer. Our observations are limited by physics itself. We cannot see beyond the observable universe. We cannot travel faster than light. We cannot access information from regions forever beyond our horizon. This creates a profound problem. Infinity may exist, but proving it could be impossible. Science excels at answering questions through observation. Yet some questions lie beyond observation. The ultimate size of reality may be one of them. Future discoveries could provide clues, more precise measurements, new theories, unexpected evidence. But the final answer may remain forever out of reach, one of the greatest mysteries in human history. So, what happens if space never ends? Perhaps there are infinite galaxies beyond our horizon. Perhaps there are infinite worlds, infinite civilizations, infinite possibilities. Perhaps there are countless versions of history unfolding across an endless cosmos. Or perhaps reality is stranger still. The truth is that nobody knows. Yet every observation we've made has revealed a universe larger than we expected. Every time humanity thought it had found the boundary moved farther away. The Earth was not the center. The solar system was not the center. The Milky Way was not the center. Even the observable universe may not be the whole story. Maybe the greatest lesson of cosmology is not how much we know, but how much remains hidden. And somewhere beyond the furthest galaxy we can see, beyond the edge of observation, beyond the reach of light itself, the answer may already exist, waiting in the darkness. Forever beyond the horizon, if space truly never ends, then the greatest mystery isn't what's at the edge of the universe, it's whether there is an edge at all, and that possibility may be more astonishing than anything humanity has ever imagined.
Thanks for watching. If this video made you pause, question, or see things differently, then it did its job. Feel free to explore more ideas here, and as always, keep thinking.